Hey guys, today I'm going to be taking a few minutes to show you how to set up the custom airplane mixer under iNav, more specifically iNav version 1.8. Now I did do a tutorial such as this quite some time ago for clean flight, but quite a few things have changed more recently and that tutorial no longer applies. The setup that I'm actually doing is going to be a wing powered by a Seriously Pro F3 Evo. It has 8 motor outputs. I'm going to be using 3 of them for servos and 1 of them as a motor. Now, I won't be having the motor hooked up in this demonstration, just simply it's not necessary. And I'll show you how to do that, including how to set up differential thrust. But for this, I'm just going to have the servos hooked up. So, for a wing, you're going to have your 2 elevons. So that's going to be, these 2 are going to represent those. And then what I've done is I've added a 3rd servo. And that 3rd servo is going to be hooked up to the normally unused yaw. And this will allow me to look left and right on my wing while I'm flying about. So to do this, unfortunately we're going to be working in the CLI. Now I know a lot of you aren't big fans of the whole DOS style command thing, but it's actually not going to be too bad. The other benefit to this is I'm actually going to show you how to create a script so that if you were to upgrade the firmware or needed to modify something later on, you actually don't have to do a whole lot of typing. You can modify a couple variables in the script and apply it to the CLI. So, first thing I'm going to do is I'm going to show you the commands that we're going to be using. Now, the first one is going to be the mixer command. There are actually 2 ways of doing this. One is, of course, under configuration, where you can simply select from the drop-down and pick your custom airplane. But because I'm going to be doing the script, I'm going to show you how to do this under the CLI. So, step 1, type in mixer, and this will give you what your current mixer is. Now, I already have this set up as custom airplane as I was playing with everything so that I could basically show you right off the bat. But to see a set of, or a list of available mixes, simply type in mixer and then list. And that'll give you a whole series of available mixes separated by spaces. When you do type in the mixers, don't type in any spaces. It's going to be a single solid word, and it's not exactly capital sensitive, so I like to do all of this in lowercase. To select your actual mixer, simply type in mixer, then custom airplane. And that will apply the custom airplane mix. Anything done in the CLI, though, don't exit the CLI until you have saved it. So, to do so, just simply type in save and press enter. And that will reboot the flight controller. So I'm going to go back to the CLI. The other 2 commands you're going to need are the MMIX and the SMIX. So these are the rules that I currently have applied, and I'll show you exactly what they do and basically what each variable represents. I'm going to start with the MMIX. Now to do that, I'm going to start using this script. So first thing you're going to want to do is, so in the event that you're updating the firmware later, is we're going to want to actually apply the mixer under this script. So I'm going to simply type in mixer custom airplane. Now every time I go to apply this script, it will just make sure that the current mix setting is custom airplane. So you will also notice that I have several lines here that begin with a pound sign. Under the CLI, the pound sign represents a comment, which means any line that begins with a pound sign will be ignored by the CLI. This way you can actually leave yourself little notes as you go, like I've done here. The first one is going to be the website in which we're going to get the actual input IDs, and I'll show you that shortly. The next one is actually the command and the variables that are associated to it. So, first thing I'm going to show you, of course, is the MMIX. Now, when working with the MMIX, you can't specifically delete an item. So if you have too many rules or too many motors applied, you can't just go and remove one of those motors. To do so, you actually have to remove all of them. So we're going to start each one of these off with MMIX reset. And because we're on this topic right now, I'm going to set SMIX reset as well. So this is just going to clear out the current MMIX and SMIX commands that are already under the CLI. And then to save myself having to type in save every time, I'm just going to put save at the bottom of the script. Okay, so let's tackle the motors. So I'm using a Seriously Pro F3 Evo here. It has 8 outputs numbered on the board from 1 to 8. But as far as the CLI is concerned, they're actually numbered 0 to 7. And that's just a computer thing. Usually whenever you're dealing with arrays usually start with 0 as the first entry and work up. So if there are 8 items in an array, there's going to be 0, 1, 2, 3, 4, 5, 6, and 7. Might take you a couple of times to kind of wrap your head around that, but just always subtract 1. Think 1 under. So 1 is actually 0, 2 is actually 1. Now under the custom airplane mix, the first 2 entries are for your motor, or the first 2 sets of pins are actually for your motors. The last 6 pins, so pins from 3 to 8, are going to be assigned to your servos. And they are numbered 0 and 1 on the motors, and then 0 to 5 under the servos. You can use any pins that you want for the servos, but for the motor, if you have 1 motor, it's going to have to be applied to the first pin. And if you have 2 motors, then of course you're going to use the first and second pin. Let's say something is wrong and you can't use the first pin, then you're going to have to apply a motor rule to the first one, and then apply the motor that you want to the second one. Will work, but you have to have something in the first slot. So just for education's sake, I'm going to actually show you how to set up differential thrust. So let's say you had an airplane that has 2 motors. Number 1 is on the left, and motor number 2 is on the right. So to do that, we're going to type in MMIX. So first of all, we're going to want to select the number. Now we only have motors 0 and 1 available to us, so we're going to take motor 0 first, which is what this is at the very top. And we're going to apply the throttle multiplier, and that's how this is actually associated. So when we give these motors throttle, we want to give them full throttle. So we're going to give them a multiplier of +1. Next is going to be roll and pitch. This actually doesn't apply to aircraft or airplanes. For a multi-rotor, you would want to speed up or slow down specific motors to allow it to roll and pitch. But under an airplane, we're just going to zero these out. We don't want to apply any roll or pitch value to our motor. Okay, so now for yaw. So whenever I like to think about anything to do with inputs to outputs, I always like to use the positive value. It just makes it easier on the brain. So motor 1 is going to be on the left, and motor 2 is going to be on the right. If I want to yaw to the right, we're going to need motor 1 to speed up and motor 2 to slow down. Now I'm not going to give it full value though. So what I want to do is I want to give it 30% of the input to that motor, and I'm going to take 30% away from the second motor. To do that, I'm going to type in 0.3. So that's our multiplier. Multiply 0.3 by 1, and you're going to get 30% or 0.3. Okay, so that is the left motor. Now we're going to need to apply the right motor. Motor 1, which is pin number 2, 1 for the throttle value, 0 for the roll, 0 for the pitch. So now, if I apply positive value to the stick, I want motor 1 to speed up, but I want motor 2 to slow down. And I'm going to want it to slow down by 30%. To do that, we're going to apply a negative multiplier. So when you give it positive input, it's going to multiply positive input by the first one, and it's going to multiply that positive input by the second one, slowing down motor 2. The plane will yaw to the right. Let's say if we want to yaw to the left. So what's going to happen is we're going to be giving a negative input to the motor. It's going to multiply that negative input by a positive input, which will still be a negative input. So this motor will slow down. And if this motor will actually be applying a negative value multiplied by a negative value. And that'll create a positive value. So in this case, 2 wrongs are going to make a right. And this will cause this motor to speed up. And that's pretty much all you have to think about. Now you may need to either decrease or increase these values to get the desired thrust rate that you want, But you can always come back to this script, edit the numbers, and then copy and paste them back into the CLI. So this is just a demonstration. This is only going to be a single motor aircraft. So what I'm going to do is I don't want to get rid of these. I'm going to leave these here for reference sake, but I'm going to comment them out. So what we want is a single motor on pin 0 with throttle, no roll, no pitch, and no yaw. And that's it. So we have our single motor applied. So what I'm going to do is copy this. And I'm actually, do you know what? Let's not get save. Let's show you actually what it's going to look like. Oops. 1 on the throttle, 0 on the roll, pitch, and yaw. Okay, so MMIX is done. That's the easy one. Next one is SMIX. So we already have the SMIX reset in there. So the way this works is instead of applying per pin basis, we're going to actually be creating rules. Okay, so the way this works is rules are going to have to be sequential from 0 up. Make sure that you get each one of those spaces. So if it's, you're going to do rule 0, rule 1, rule 2, rule 3. If you have to comment out one of those rules, you will need to change the order following them so that they're still sequential. If not, anything that's after that rule won't be applied. So first thing we're going to do is we're going to apply the first rule, SMIX, rule 0. Okay, so that's our rule number. Next one is going to be the servo number. So remember, on this one, servo pins 3 to 8 are going to be designated for servos, and those are going to be applied numbers 0 to 5. So we're going to select servo 0, which is going to be on pin 3. So next is going to be the actual input ID. Now to get that, we're going to have to go to the iNav website, and I'll put this in the description so that you can easily get here. And you're going to need to scroll all the way down the page until you get to the flight control output signal sources. Okay, so these are your input IDs for each. Now there's a reason why they do this. Okay, so available to you are things like stabilized roll, pitch, yaw, and throttle, and then you have RC, roll, pitch, yaw, and throttle. So anything run through the stabilized roll, pitch, yaw, and throttle will, depending on what mode you're in, will actually apply the whatever stabilization algorithm to the input. So when you pitch, if it's moving around, it's going to cause it to it will cause it to correct itself. But if you've got something like the camera where you apply a roll, well, you don't want it to actually have the whole stabilization algorithm into it. You want to apply the RC roll. So that's why we have things like stabilized roll and RC roll. And of course, because the numbers then go up from there, we have our 4 available auxiliaries. We have things like gimbal pitch and gimbal roll, which is basically stationary. And then you can actually mix those with other inputs as well to get the desired output. And then you have things like feature flaps, where the plane may automatically apply flaps, and that is going to be on pin 14, or ID 14. So because this is a wing, the two we're going to need are stabilized roll and stabilized pitch. Now, don't get confused by that. If you are in pass-through mode, you still want to use the stabilized inputs. It just will apply the input values directly to the outputs without stabilized. But you want to have that as an optional so you can turn off pass-through and use everything. So you're going to use stabilized pitch and roll for your actual controls. So the ID we want, we're going to start with roll, so we're going to use ID 0. So the input ID is going to be 0. So far we have a few zeros, but that's okay. Next is going to be rate, and this is just going to be exactly what you think. So we're going to be applying that input to that 0, or to that servo at, let's say, 100% rate for now. And the last variable is going to be speed. And what speed does is it actually will limit the travel at which that servo can move. Normally you wouldn't need this, except for, let's say you were using a gas or nitro plane, in the event that exceeding a certain throttle speed or decreasing by a certain throttle speed may either flood out or stall out the aircraft, and at that point that would probably be pretty bad. So you can actually limit that here so that you can't over accelerate or decelerate or whatever. But we're not using that for this electric plane, so I'm just going to zero out the speed, which will basically tell the system to apply as fast to the servo as I apply to the input. Okay, so because this is a wing, it's going to have two control surfaces that are going to depend on that input. So the second one is going to be SMIX bool 1, and we're going to be using servo 1, which will be on pin 4, and we're still going to be using that same input ID. Now, to do a roll, you're going to want one servo to go in one direction and one servo to go in the other. Because they are actually opposing each other in this setup, you're going to want to apply the same rate to each of them. And we're just going to zero out the speed. Now next is going to be the pitch. Okay, so if we went back over to here, you'll notice that stabilized pitch was ID1. So we're going to SMIX rule number 2, which is actually the third rule, and we're going to reapply this now to servo 0, except for we're going to be using input source ID 1. Now, to kind of save on a lot of thinking and show you how this script will be beneficial to you later, I'm just going to type in 100 for the rate and zero out the actual speed. Now, because these are opposing servos, when you apply pitch, you're going to want one to be going clockwise and the other one to be going counterclockwise, and vice versa in the other direction. So to do that, this will be rule number 3. This will be applied to servo number 1, same input ID, except for I'm going to apply a negative rate. Okay, so this will add the opposite movement to the other servo, and we're going to zero out the speed. So I'm just going to do that right now. So this is a basic wing setup. This is pretty much all you really need to have. So I'm going to copy and paste that into the CLI. Okay, so there you go. That was the last command issued, and if we type in SMIX, there you go. So now, if I was to save that and press enter, the flight controller is going to reset itself. Okay, so now we have pitch and roll. Now let's verify that these are actually in the right direction. So let's pretend the elevons are back here. If I apply forward pitch, well, that's going to push backwards, and that's going to push both elevons down. That's right, you want your elevons to go down, which will push the back up and bring the nose down. And if you were to pull up, brings them up, pitch is up. So we know pitch is right. What about roll? So if I want to roll to the right, I want this one. See, okay, what's happening is if I want to roll to the right, this one's pulling up and this one's pushing down. That's actually in the opposite direction. Same thing in the left. So what will actually be happening, if I want to go left, or if the aircraft wants to go left, it's actually going to go right. Not good. So let's go back to our script. And 0 was our roll value. What I'm going to do is I'm going to apply a negative rate to both of those. Copy. Oops. Back to the CLI. And this is where that script is going to come in very handy. Paste and save. So I've applied negative values. So the flight controller is now rebooting. Okay, so now when I roll to the left, this is going to go up, and this one's going to go down. That'll cause it to roll to the left, and that'll cause it to roll to the right. So now that I have the proper stabilized values being sent through, even if you're in something like return to home or loiter, the aircraft will actually output the proper commands, and then the control surfaces will move exactly how they want to move. Okay, so that, though, doesn't solve our camera issue. So what I've done is on pins 3 and 4, I've attached my elevons. Now to show you that you don't have to be directly in order, I've attached the camera servo to pin number 8, which is actually going to be servo output 5, right? So it's the 6th output, but because it's in CLI speak, it's going to be 0, 1, 2, 3, 4, and 5, right? So to do that, let's go back to our script. Okay, so SMIX. Now this is going to be the fourth rule, and this is going to be servo number 5. So okay, so now we need the input source ID. Now we have both stabilized and RC inputs available. So RC inputs is no stabilized algorithm whatsoever, no mode algorithm. When we're using a camera, we don't want the plane to be hitting turbulence and kind of jarring and yawing left and right. So if that was to happen and we were on stabilized inputs, then the camera would be kind of moving left and right with it. Might look better, but you might not kind of get that feel that the plane is actually kind of yawed a little bit to the left or a little bit to the right, and we don't want that. What we want to do is we want to give it direct input. When this is center, we want the camera to be center. When we want to look left, we can look left, we can look right. So we don't want to give it a stabilized input. We want to give it the RC input, and that ID is 6. So we're going to head back over here. We're going to apply ID 6, 100 on the rate, and 0 on the speed. So I'm just going to copy everything, including the save, paste, and enter. Okay, we'll give it a second for the flight controller to reboot. Go back and CLI. Okay, so now when we want to yaw one way, the camera goes one way. When we want to yaw the other way, the camera goes the other way. Unfortunately, though, it's going in the opposite direction. We want to look left, we want to look right, and it's going the other way. Let's go back to our script real quick. Very easy fix. We're going to apply negative, copy, which I just pressed Control C there. I'm going to press Control V here to paste. Flight controller is rebooting. Okay, so while that reboots, now I can look left, now I can look right. Just that simple. Okay, so I'm actually going to mix a couple other things into this. So one of the things I like to do with my wings, because it's a real pain in the butt, and normally you shouldn't really touch these, because as you're switching from mode to mode, your trims may affect the plane differently. So what I'm going to do is I'm going to set up these guys to actually trim out the aircraft, right? So this one has a center, so I'm going to use this one for the roll, and this one doesn't. So I'm going to use this one for pitch trim. Okay, so I have set this one to auxiliary 1, and this is auxiliary 2. So let's head back to our script. Okay, so I'm going to type in SMIX. This is rule number 5, so we're getting up there, but I mean, it's great. You can actually mix this any way you want, add any combination. Let's say you have something like a camera switcher, so like a 3-way camera switcher, which I have a bunch of, and I love them because you can put a camera at the front of your wing, you can put a camera at the back of your wing, you can put one out the side, and be able to use one of your switches to actually switch between which camera you want to use. That camera takes a servo input command to select its position. You can do this all under the custom mix, very easy. Okay, so rule number 5. Now, once again, because this is going to be dealing with the elevons, I'm going to apply to servo 0. Okay, so now we need to know what the ID is for auxiliaries 1 and auxiliaries 2. So let's go ahead back on over here. ID for auxiliary 1 is 8. So I'm going to apply 1. I'm going to apply a positive value, 0. So this is for roll. Oh wait, I didn't want. I wanted this for pitch. So what I'm going to do is let's do that. So auxiliary 2 is going to be for my roll command. Oh wow, I really messed up here. Excuse me. So auxiliary, so input 9, 100. Now remember, these are opposing servos, and because this is for roll, I'm going to be keeping the same value on both sides because they will move in the opposite direction anyway. Input was still 9, and I'm going to stay with 100. So let's copy that, head back to our CLI. I'm going to Control V to paste it in and press enter. Okay, flight controller is now rebooting. Okay, so now what this does is this allows us to use this to trim. So let's say you're flying and your plane is rolling to the left. You can actually counter it by basically causing it to roll a little bit to the right. So this allows you to very easily trim your roll while in flight. And we want to do the same thing for pitch. So we'll go back to our script. SMIX 7 is the rule. Servo was 0. And the input ID was 8 for auxiliary 1. So we'll enter 8, 100, 0, SMIX, rule 8, servo 1, input ID 8, and because they are, of course, opposing each other, we're going to do the negative 100 and 0 out the speed. Okay, flight control is rebooting. Okay, so now there's our pitch adjustment, so we can trim pitch while we're up there and roll. Not to mention fly, look left, look right, and of course throttle if I had a motor on board. And it's just basically that simple. So another little issue I've seen actually from a few people is that you're finding that your servos just aren't moving enough, or your control surfaces just aren't moving enough. So that little guy is actually under PID tuning. So if you go to PID tuning, you get this number here. Now, by default, this is normally 200. Usually more than enough to control a wing as long as it's trimmed properly. But if it's not, you may want to have that throw. So by changing that value, so now, if I do this, you'll notice they move that much. And if I go to 100, so this is for roll, let's do pitch. Just because pitch is more obvious on the camera. 100, save. Now you notice that we move less. Increase this to 500. So this is before I hit save. Press save. And this is after hit save. So that'll actually allow you to adjust that. Okay, so next, we have all the servos set up the way we want them, except for now we need to set the midpoints. You may also need to actually adjust your maximum, like your throws, for your minimum and your maximum, so that, let's say, if you pitch forward and you just don't have the room, or the elevon is moving up too far because it's hitting something, or it's just bending too much. If you go to the servo tab, this is where you actually set up that information. So this is where you're going to do all that. Now, this is the same thing. It's going to be servos 0 to 5, except for here's where you set your midpoints. So you have your two sets of rates. You have your rates that you apply to the SMIX, which is that input rated to the servo. And then you have your servo's actual rates and midpoints and all that. Ignore the rate on this page. Do all that under your SMIX. For here, though, so for me, I'm happy with the midpoints on those. But let's say I wanted to move this one back, because this one is a little bit more forward. So I'm pretty sure this is servo 1. If we enable live mode, we can now decrease one of these servos. So I'm going to go 14. So usually it takes pretty good movement. I'm just going to do this as an example. I'm going to set this to 1200. And, oh, okay, so it's on this side that it's moving. So we want it to move in the opposite direction, so we want to go above 15, let's say 1800. All right, so this is how you actually adjust your midpoint, and it's quite obviously how it's stated. I'm going to leave it at 1500. This is how you set your max. So this is our max throw, but let's say this can't move all that way up. It can only go to there. Let's set our max to, like, I don't know, 1600. Let's do it on the other servo. Okay, so now you'll notice that this one is restricted in the one direction. And it's not max I wanted to change, it's min. So we'll do that here. Say 1400 and take this one back to 2000. If at first you don't succeed, try another variable. Okay, so now you'll notice that it stops on its own. So that's how you set your mins and maxes. Pretty easy. And your midpoints. We store these. Now the one that I am having trouble with is this camera is a little bit off angle, and unfortunately I can't get that servo centered enough on the tooth. It's either too much off to the left or too much off to the right. To fix that, because I put it on servo 5, so if I actually had 10 motor outputs, I could use all of these, but I only have 6 outputs. So, or I should say, if I had 10 outputs in total, 8 servo outputs, I could do that. But this flight controller only has 6 servo outputs. So now I need to adjust my midpoint on the camera. So I'm going to go, let's say, 1400. And that's almost there, but I went a little bit too far. So let's go 1430. It's almost there. Let's say 1420. And what I'm doing is I'm actually pressing enter in live mode to kind of just activate it. And that's about center. And that's it. I've set up my custom wing under custom airplane as the mixer. I've applied a servo as to use the unused yaw. I have my roll and pitch. I have my ability to trim my pitch while in flight very easily. Right? And I like to leave this there on pretty much all my wings, because let's say one time I take off, I'm a little bit nose heavy or a little bit tail heavy, or, I mean, there's a lot of different reasons that you may need to actually control these in flight. It's a nice to actually have them available to you. So that is custom airplane mixing. I mean, I can't really tell you much more than that. I think we pretty much covered everything. So any of you out there, I hope this really helps, and happy building. I mean, it's very gratifying to get one of these things into the air, and I mean, have fun.